Hello, check. Okay. Hello, sorry. I'm just trying to focus on the problem because I want to move as fast. Because I don't think I could do as much or as long as the stream because I need to sleep early. But yeah, so we're learning a little bit of OOP with JavaScript. We're creating the methods and trying to simulate a shopping cart for some dessert shop. So yeah, here trying to make the methods of the shopping cart class, which, not gonna lie, this is a lot, but it is what it is. Okay. Okay. The first thing you should do is check if items alert your shopping cart is already empty. Then return. You should create an if statement that checks if the item's array is empty. Remember that 0 is a falsy value. You can use it to check if the array is empty. After displaying the alert, return the function. Okay, check if items array is empty. Okay, so if items like that. Here we go, guys. 3 more steps. You only want to clear the card if the user confirms the prompt. Create an if statement that checks if the user confirms the prompt. In the if statement, set the items property back to an empty array and set total property. Okay, so if is card cleared, which is a truthy, I would assume. So this 5 times plus 2 0a. This total goes to 0. Nice. You also need to start clearing the HTML. So products container inner HTML. Got 2 empty string. Set the text content of the total number of items dot text content equals to 0. Card subtotal dot text content equals to 0. Card text dot text content equals to 0, and card total dot text content equals to 0. Cool. This should be all. If I says to make your clear button functional, add a click event to clear card button. I think it's just gonna call that. Okay, so we can do that. Sorry, we can do dot add event listener. Listen for a click, and in the call it function, we should pass card dot clear card. Okay, clear card dot bind dot card. That's the callback. Okay, cool. Awesome. Okay, nice. Yeah, I'm not doing this again, bro. So we already finished 70%. Wow. Nice. So, okay. Yeah, we already tried that. I just forgot the this. The this. Okay. Recursion. My worst enemy. Always have a base case, okay? Will you watch Markiplier movie Iron Lung someday? I'm not sure, or I don't know. I don't know. Is it available in Germany? What? Really? Where? I didn't see it. All I saw was like Avatar. That was um on the theater. I haven't really seen any advertisement of it here, so I I don't know where if I want to watch it. Cause last time I checked, there's no mention of Iron Lung in the theater. In this workshop, we'll be creating a quantum function that creates an array with number from 1 to a given number using recursion. Start breaking an empty function. Count up. Now, add an if statement inside of your count up. Check if number is less than 1. Return. Is it like that? Return empty array. Okay. Okay. You should assign the result of calling count up with number. Like that. I'm still not quite understanding how it works. I guess if, okay. We need some videos, I guess. Recursion, visualize, JavaScript. Is there any like 5-minute videos? Just like, okay, here we go.
Recursion in JavaScript. What is recursion in JavaScript? What is recursion in JavaScript?
Ha,
What is...
nice.
Okay, stop. That's enough. In this video, I'll be simplifying the concept of recursion in JavaScript. Recursion is a concept where a function calls itself and keeps calling itself until something stops it from calling itself, just as you saw at the beginning of this video. So a recursive function works just like a loop. In for loops, in while loops, you have your condition, for which as long as that condition is true, the code that you have specified will keep running until the condition becomes false. That is the same thing with recursive functions. The function keeps going as long as the condition that you have specified is true. And if that condition remains true forever, just like you have infinite loops, you are also going to have infinite recursive function calls. And as you would expect, that can crash your browser or crash your application. There are so many advanced use cases of recursive functions, but in this video, I'll be using simple examples to simplify what recursive function means for you. So let's jump straight to the code. I'll be using this simple example here to explain what recursion is in JavaScript. So here we have declared this function which says print hello, and what print hello does is that it just logs hello to the console. So here I can call print hello like this. If I come here and I run this file, you can see this is hello. Now just as I have called this function here, I can also come inside this function and call the function again, and this is what we mean by recursion. And just like I said at the beginning of the video, recursion is a concept where a function calls itself. So here when we call print hello, this is going to execute this function, and then it's going to log hello to the console, and it's going to call print hello again, and by calling print hello again, that means it's going to come back here, console log hello, and it's going to call print hello again, and doing that comes back here, comes here, and then you have the recursion that keeps going and keeps going and keeps going. And I can try this, and you can see when I run this, my application is most likely going to crash. Okay, so you can see a lot of hellos here, which is the recursion happening, and then because the maximum call stack is exceeded, you can see that the application has crashed. So this is an infinite recursive function which you do not want in your applications, as it can cause your applications to crash. Now when you have things like loops, let me just quickly declare a loop here. So I'm going to say let's counter equals to 0, and then we're going to say counter less than 7, and then we're going to say counter plus plus, and then here we come here and we console.log hello. So if I come here now and I run this file, you can see that hello is logged 1, 2, 3, 4, 5, 6, 7 times, because the counter remains less than 7. And at the moment where the counter becomes a number that is not less than 7, this loop is going to stop. So we have this condition for which, if it is always true, this will be executed until it is false. We can do the same thing in recursive functions. So with recursive functions, we can declare a base case, and the base case in a recursive function is the condition for which, when that condition is met, the recursive function is going to stop its recursion. So how do I declare a base case? Outside here, I can just declare a counter and now initialize this to 0. And when I console.log hello, I'm going to increase the counter like this by adding 1 to it. And then just down here, I'm also going to console log the counter. For my base case, I'm going to say if counter is greater than 6, then I'm going to return. It doesn't matter what I return here, I can just use the return keyword. So this is going to tell the recursion that once it meets this base case, then stop the recursion. If I come here and I clear this and I run this file again, you can see hello is logged for the first time, which is this. The counter variable is increased by 1, which makes it 1, and then when we console log it, we have 1 here. This base case is not met yet, so the function is called again. This is where the recursion begins. We have hello, we have 2, we have hello, we have 3, we have hello, we have 4, 5, 6. Now when the counter becomes 7, our base case is met, because we said if counter is greater than 6, it should return. And because 7 is greater than 6, it's going to return. And you can see the function calls stop here, and it doesn't proceed to this place. So this is how recursive functions can be used to execute some lines of code until a condition is met, which is the base case. And when that condition is met, the recursive function stops. This is not exactly a replacement for loops, but in some cases, it can be more effective than using the regular for loops or while loops. If you enjoyed this video, please give it a like. Also subscribe and turn on notifications.
Recursion, if you write base case first, it makes writing a lot easier. Well, this was pretty simple in the sense that it's just writing a count up, but I guess I don't know how to visualize it. Like, okay, visualize JavaScript. I think I saw a website where it would like draw the call stack and everything, so it would be much easier to understand. So let's do that. Okay, cool. Okay, let's try to visualize them because okay, count up. So the function is put in the call stack. Next, it's another count up. But like, what's the value of it? Like count up again, and then console log, I guess. Okay. Let's try another one. Let's see if this is better. Okay. So, okay. Step about execute count up value scope. Okay, we're calling the count up the first time because technically it's only function, identifier, numerical literal. Oops. Go to execute statement of type variables. 5. Okay, so we have number 5, and since 5 does not do that, it's false. It's going to count up again. 5 minus by 1 is 4. Okay, so about to execute the statement again since it's empty. it's gonna be 4. Compare it again. Why doesn't it go with the push? Okay, so we got the 2, and then finally we hit 1. Oh, so we're not gonna do the push. When did we do the push? Oh no, during the checks, we always do the push, right? Oh, no. That okay, when did we start pushing then? Okay. What's the control array supposed to hold? So everything happens when you start returning out. So it's just gonna count. It's just gonna put the number of the uh yeah, sequentially until that parameter. I'm just a bit unclear, like why does that mean as long as the doesn't hit the base case, the count array would just call the count up until it hits the best case? But why does this why pushing the number only happens until like this? Okay, I'm gonna ask who is the smart one, yeah? I don't know. Gemini? Not cool. I don't know. But nothing go okay, in recursion the stack will build for every time the function is called, but nothing goes to the next line until the last execution returns out. Yes, every call just gets added to the call stack and doesn't continue on until you hit the best case, which doesn't happen till the very end while num equals to 0. Okay, so after it hits the best case, it's finally starting to push it. Function that solves a problem, solving solution of this world. You're like a set of Russian nesting dolls. You can get the tiny doll in the center, opening the bigger ones, and you can close the big ones back up until you've put the small ones back inside. Okay, a regression function needs to think. The best case, this is stop signal. The recursive step, this is where the function calls itself, but with a small version. The waiting room. Okay, so if we use plus, that means it will be the same, right? It's just gonna Stack Overflow. Oh, that's why in the other visualization, the count up is just hold in the. Okay, I get it. Okay, it's just stuck in the call stack until it. Okay, yeah, okay. This is why it works. When a function call itself doesn't just disappear, it pauses and sits on a call stack. It waits for the new functions to call to finish before it can move to the next line of code. Cannot run until count number one is completely finished and return a value. It's just a really cool. Now that count up 0 return an empty array, the pause function can finally wake up and finish their work in reverse order. Oh, okay. Okay. The numbers are pushed in the order 1 to 3 because the function for 3 was the very first at the start, but the very last, so last in, first out, last in, first LIFO. The math classical, okay, yeah, factorial. So as always, the best case is 1. 1 is going to be returned to 1. And the recursive step is just the number multiplied by the recursive, where it's going to decrease over time. So it's going to be 5 times factorial 4, back again to factorial 3, factorial 2, and then when it hits like 1, it's just going to return 1, and then like, okay. I'm still, yeah, okay. I think the visualize this one actually better to do it then. Like, let's say we run, call the first count, call the second count, third, fourth, fifth, and when it's already done, let's go back, push the number 1, push number 2, push number 3, push number 4, push number 5. Okay. What about this one? Basically, when the last count of called, it returns and then push the return, not then push, then return, then push, then return. That's like the task. The task. Oops. To create. Okay. Factorial should be better. Okay. Yeah, for the factorial it makes sense. For the other one, yeah, this one, I'm not sure if that's a good example. It's not gonna lie, that's kind of confusing. This is the base case. Otherwise, countdown should return an array containing the integers from n down to in descending order. The function should call itself and must not use loop for any kind. Each recursive call should have a small value to the previous. So it's just gonna return countdown n minus 1, like that. But not really, is it? Bad example. This example of recursion usage Ah, stupid, it's just asking you to output the numbers counted order. Yes, yes. So if I want to do it in reverse, how would I do it? Hmm. Each recursive call reduces smaller value than the previous call. If n is less than 1, consider an empty array. You must use recursion and must not use loops. Each recursive call use use call variables to store or cache the result array. Click on all of them. That's your always return the correct independent result. Which is why it's confusing. Okay. Okay, so we can't just do this one, is it? Do I need to like return countdown and -1? Okay, no, that doesn't work that way. You should use recursion to solve it. Global variable should not be used to cache the array. Okay, so how can we not use... Okay, I'm gonna... I don't think it's work this way. Hello. It's nicer if you kept count array outside of the function, which would probably fail the test case. But that will probably just to help understand. Okay. Can you do it like this? I don't think so. Can you? I'm not sure, yeah. I don't think it will work. Yeah, okay. No. That's not it. If I couldn't. Okay, it says that I cannot use other array, so I'm not sure. Okay, let... I don't think it's possible to do it this way, is it? Oh, okay. Wait, what? That work? Oh, whoa, hold up, wait, what? Okay, never mind. I wasn't expecting it to be as straightforward as that. Um, uh, shit. What is it reset? Why is it resetting? Okay. I thought I couldn't. Okay, so I cannot use a global variable, but I can use the scoped one. Okay. Okay. Does the final result print 5 lines of console logs? Which one? Oh my god, which one is it? Um, so data structure is not yet. Algorithms are regress and trees also coming. Dynamic programming is coming. Functional programming is coming. And I think asynchronous. So I think we can really finish this by the end of the week. Although, okay, I think yeah, I was surprised. I think last week we were on like 300, or 500, so we're almost like 70% done. We skip a lot, oh, yes, but like it's fine, right? We can go back to get like the certification some other time. Okay, a lot of the node stuff is not here, which is okay because I really wanna focus more on the basics. So I think let's do. I think I want to make the Astro website, if I'm not mistaken, after I finish this. So let's do that. Um, I think it is faster, of course. Probably like 2, 3 times faster. So yeah, it is way faster. It was way better to just read what it was tasked because I guess again it was my fault. Sometimes I like read fast and then like, oh, it's do this and it's not. Oh no, you need to read until the end so that the task could be presented properly. Okay, Roger that. Wait, sorry, man. I really need to start opening Discord more. So sorry, I just not entirely sure how to. Maybe I should learn just community management, right? In activity, Here you go. Okay, I couldn't really see. It's just a text. I'm unsure. Is it in memes? When the interviewer doesn't want to hire you. Do we need ASCII? ASCII character? In stream alert. Wait, I couldn't really see it. I don't know why. Oh, there we go. Okay, okay. I saw it. I saw it. Ah, okay. So, oh my God, what terminal are you using? It looks so nice. Okay, okay. So the first is the count of five, right? Okay. And then it calls the count of 4, 3, 2, 1 until 0. And once it returns the empty or ghosty. I don't think ghosty is available on Windows, right? Yeah, no Windows. So it's gonna. I think it's my understanding of the call stack is still not. I don't know. Even though I think we watched the video explaining the call stack and everything, but in a case of recursion, it still confuses me. But it goes from line 6 to 1. Okay. And once it returns, it goes from. Okay, so it goes. And once it hits the base case, it's gonna start continuing with the that. But okay. The for call stack, don't use it. So once it's reached the base case, then it could start this, the pushing to the array. Okay. That web for call stack, don't use it for this example. Okay. Okay. It's for the event loop in your browser. Okay. Hmm. This is 100 steps. Maybe some other time, yeah. But yeah, I guess that's pretty nice. I don't. Yeah. Okay. Thank you for the explanation. But I do have to say that I couldn't really do as much or as long stream because I need to wake up early tomorrow. So I think for the next one we can just do the functional programming and then asynchronous just to speed things up a little bit. This is still an next important concept. A side effect is any change that occurs in the state of the program when a function is called. Modifying a variable, writing to a file, or making an API call. Pure functions have no side effects, but impure functions have these. When we minimize side effects, our code becomes more predictable and easier to test. While writing code, our main goal should be to make functions do one thing, and they should do it very well without changing other parts of our program. Here is an example of a function with a side effect. Hello Alice, greet Alice. This function has a side effect because it interacts with the outside world by logging to a console. My favorite is return hello Alice. Okay. Create this function that simply returns a string, and we handle the side effect separately. To compose our programs using pure functions by breaking our code into small, predictable pieces, thus we can build programs that are easier to understand, test, and maintain. Let's produce the same output, whichever one is considered a side effect. Modifying global, what is the benefit of avoiding side effect? It makes the code easier to understand and test. What is currying and how does it work? Where it transforms a function that takes multiple arguments into a sequence of functions, each taking a single argument. Okay. Recursion can be broken into three parts: pre, recursion, post. Pre is where you check the base case, post is everything what happens when you start exiting out. Okay, so now this is what we did, the countdown. Imagine you're looking for a file script. This is a folder. The folder is okay. Look at all files in the current folder. But you don't know how many levels deep. To try a small challenge where you write recursive function to sum all numbers in an array. Post is everything that happens when you start exiting out. So that the other side that looks like a stair down where it starts to push the number into the array, right? Now let's see if you can curry this function. Curry the A, return function B, return A plus B. What? In this curry, converts the code. Instead of taking two arguments, we have a function that takes the first argument and returns another function. This return function then takes the second argument from the addition. We call it curry tree, where each pair of parentheses represents a function call. Huh? What? We could create a function that always adds 5 to any number. Oh, okay. Okay, so it's those type of use cases. Okay. Okay, I guess that's it for today. I think I'm gonna try this. I don't know if I can do it tomorrow or I'll try some other day. But yeah, I hope everyone have a great day. Sorry for making it a bit short because I couldn't really do it too long because I need to wake up early tomorrow. And yeah, I hope everyone have a great day, afternoon, night, wherever you are. Yeah, I think we can finish this and then we can start to, yeah, because I need to make this landing page / marketing site. So let's do that while learning it. I want to try Astro because like it's super fast. People said because yeah, it doesn't ship JavaScript, but we'll see. Thank you. We'll continue. Continue again. But yeah, hope everyone have a great day. Sorry for making it a bit short, but yeah, I have to wake up early tomorrow. So everyone have a great rest, and hope you all are having a great day or night or noon or whatever it is.